At 14:23 on the afternoon of the 9th of March, 1943, Petty Officer Robert Fletcher stood on the stern deck of HMS Starling, watching the ship's standard-issue depth charges roll off their racks toward a German U-boat he'd been tracking for the previous 40 minutes. Fletcher had spent 8 months developing what every Royal Navy Ordnance officer called an unauthorized and dangerous modification to approved depth charge deployment. A simple mechanical delay system, built from salvaged clock springs and brass fittings that allowed depth charges to sink deeper before detonating, reaching the crushed depths where German U-boats had learned to hide beyond the reach of standard British anti-submarine weapons. The Admiralty had rejected his proposal 3 times, citing safety concerns about unauthorized ordnance modifications, and arguing that German submarines didn't operate at depths beyond standard depth charge effectiveness. Fletcher's testing data suggested otherwise. U-boats were routinely diving to 400 feet when attacked, well below the 250-foot maximum depth setting on standard British depth charges. He'd built his modification anyway, using materials from the ship's workshop, installing it on 6 depth charges against explicit orders forbidding unauthorized ordnance tampering. In approximately 90 seconds, those charges would detonate at 380 feet, 130 feet deeper than regulations allowed, and either prove that a machinist's mate from Liverpool understood submarine warfare better than the Admiralty's ordnance experts, or kill everyone aboard HMS Starling through premature detonation of improperly modified explosives. This moment mattered because the Battle of the Atlantic was being lost through simple geometry and German tactical adaptation. In early 1943, German U-boats were sinking Allied merchant ships faster than replacement vessels could be built, roughly 600,000 tons of shipping per month, a rate that would starve Britain and prevent the buildup of forces needed for invading Europe. The primary problem wasn't finding U-boats. Advances in radar, sonar, and signals intelligence had dramatically improved detection. The problem was killing them once found. German submarine commanders had learned that British depth charges were set to detonate at maximum depths of 250 feet. So when attacked, U-boats simply dove to 350 or 400 feet and waited for the attack to end. British destroyers would drop dozens of depth charges that exploded harmlessly above their targets. German submarines would surface after the attackers departed, and the same U-boats would continue sinking merchant ships. The Royal Navy's official solution was developing new depth charges with deeper settings, but procurement and testing procedures meant improved weapons wouldn't reach operational units for 12 to 18 months. Fletcher's analysis suggested that timeline was unacceptable. At current sinking rates, the Allies would lose the Atlantic before improved depth charges entered service. His solution was mechanically simple. Modify the existing depth charges hydrostatic fuse to delay detonation, allowing the charge to sink an additional 130 feet before exploding. The modification required no new components, just clock springs, brass fittings, and machinist skills he'd learned in Liverpool's shipyards. The Admiralty had rejected it because unauthorized ordnance modifications were explicitly forbidden. Testing couldn't be conducted safely under combat conditions, and ordnance officers didn't want to encourage sailors to tinker with explosives based on amateur engineering calculations. Fletcher had built the modification anyway because German U-boats were sinking ships, British sailors were dying, and waiting 18 months for proper procurement channels to produce official solutions meant watching convoys burn while proper procedure was followed. The U-boat 400 yards ahead of HMS Starling was about to discover whether a Liverpool machinist's understanding of hydrostatic pressure and mechanical delay systems was correct, or whether the Admiralty's concerns about unauthorized explosive modifications were justified. Either way, Fletcher's career was probably over. Unauthorized ordnance tampering was court-martial territory regardless of results. The Liverpool shipyard worker who understood pressure. Robert Fletcher grew up in Liverpool's dockyard district, where his father worked as a pressure vessel inspector, testing steam boilers, hydraulic systems, and pressure equipment for merchant ships under construction. By age 14, Fletcher was apprenticing in the same trade, learning that equipment operating under high pressure failed in predictable ways when design parameters were exceeded, and that understanding failure modes allowed you to design systems that functioned reliably at pressures that would destroy improperly engineered equipment. His father had taught him the fundamental principle that would later sink 7 U-boats: Pressure-activated mechanisms were remarkably reliable because physics was consistent. Water pressure at 300 feet was always the same. Mechanical systems responding to pressure behaved predictably, and if you designed a pressure-activated device properly, it would function identically whether tested in a pressure chamber or deployed at depth in the Atlantic. The challenge wasn't complexity, it was precision. A pressure fuse that detonated at 250 feet instead of the intended 350 feet would kill everyone aboard your own ship. A fuse that never detonated wasted explosives, but a properly designed pressure-activated delay system would work exactly as calculated because physics didn't allow improvisation. Fletcher had learned to calculate pressure loads, design mechanical systems that responded to specific pressures, and test pressure-activated mechanisms using workshop equipment that simulated deep water conditions. By age 20, he could look at a pressure-activated device, calculate at what depth it would trigger, and design modifications that changed activation depth by adding or removing mechanical components. His father had taught him that the best pressure systems were simple. Fewer moving parts meant fewer failure modes, and mechanical reliability came from understanding physics rather than from complicated engineering. He brought that pressure systems expertise to the Royal Navy when he enlisted in 1941. During training at HMS Collingwood, instructors taught standard depth charge operations, roll charges off stern racks, hydrostatic fuses detonate at preset depths, explosions damage or destroy submerged submarines through pressure waves. Fletcher learned the procedures competently, but he immediately recognized that the standard depth charge's 250-foot maximum setting was a fundamental limitation. German submarines could simply dive below that depth and escape. When he asked instructors why depth charges weren't designed to reach deeper, the response was that German submarines couldn't operate effectively at depths beyond 300 feet due to crush depth limitations, so 250-foot charges were adequate. Fletcher's shipyard experience said otherwise. He knew German pressure hull construction was sophisticated enough to operate routinely at 400 feet, and that British assumptions about German depth capabilities were probably wrong. When he suggested during training that depth charges should be modified to reach at least 350 feet, his instructor had dismissed it. Petty Officer, if the Admiralty believed deeper detonating charges were necessary, they'd issue them. Since they haven't, your concerns are noted but not relevant to your training. Fletcher had filed that response away as institutional resistance to field observations contradicting official assessments. He'd also started thinking about how to modify standard depth charge fuses to delay detonation, using pressure vessel principles he'd learned testing boilers in Liverpool. The pattern that kept losing convoys. The casualties reached crisis levels during the winter of 1942-43. German U-boats were operating in wolf packs, coordinated groups attacking convoys with overwhelming numbers. Allied convoy escorts would detect submarines, conduct depth charge attacks using standard procedures, and report successful engagements. Post-attack assessment would show no U-boat wreckage, no oil slicks, no debris, just German submarines that had survived attacks and continued operating. On the 14th of January, 1943, Convoy SC-118 lost 13 merchant ships to U-boat attack despite being escorted by 9 destroyers and corvettes. The escorts conducted 37 depth charge attacks, expending over 400 depth charges. Post-attack assessment confirmed 0 U-boat kills. Intelligence decrypts revealed that German submarines had simply dove to 350 feet when attacked, waited for depth charges to explode above them, then surfaced and continued attacking the convoy. On the 21st of February, Convoy ON-166 lost 14 merchant ships. Escorts conducted 41 depth charge attacks using 530 charges. 1 U-boat possibly damaged. The pattern was consistent and devastating. British escorts were finding U-boats, conducting attacks per doctrine, and achieving negligible results because German submarines operated below British weapons' effective depth. By early March, statistical analysis showed that depth charge attacks were achieving roughly 3% kill probability per engagement, meaning escorts needed to conduct 33 attacks to destroy 1 U-boat on average. At that effectiveness rate, German submarine construction could replace losses faster than Allied attacks could sink them, ensuring Germany maintained or increased operational U-boat strength despite Allied anti-submarine efforts. Fletcher, serving aboard HMS Starling as a machinist's mate, had been analyzing attack reports and calculating that depth charges were failing, not because British tactics were wrong, but because German submarines were exploiting a simple geometric limitation. They dove below British weapons' reach. The solution was mechanically straightforward. Modify the hydrostatic fuse to delay detonation by the time required for charges to sink an additional 100 to 150 feet. The modification required understanding pressure-activated mechanisms and having the machinist's skills to fabricate delay components, both of which Fletcher possessed from Liverpool shipyard work. On the 2nd of March, 1943, he'd proposed exactly that modification to Lieutenant Commander Peter Gretton, HMS Starling's captain. Gretton had forwarded the proposal to Admiralty with strong endorsement. The response had been swift and negative. When Admiralty said Ordnance modifications were forbidden, the Admiralty's rejection arrived on the 5th of March, 1943, delivered via signal to HMS Starling while the ship was conducting convoy escort operations. The message was explicit and institutional. Proposal for field modification of depth charge hydrostatic fuses is denied. Unauthorized modifications to ordnance equipment are strictly forbidden per Admiralty Fleet Order 1247. Safety testing of pressure-activated explosive devices requires controlled laboratory conditions not available aboard operational vessels. Petty Officer Fletcher will cease unauthorized experimentation with depth charge mechanisms and return to assigned maintenance duties. Any further ordnance tampering will result in disciplinary action. The rejection was logical from institutional perspective. Encouraging sailors to modify explosive devices based on amateur engineering could result in catastrophic accidents. Official ordnance had been designed by professional engineers following established safety protocols, and field modifications bypassed the testing that ensured equipment functioned safely. Better to develop improved depth charges through proper channels than risk ships through unauthorized explosive modifications. Lieutenant Commander Gretton had called Fletcher to his cabin to discuss the rejection. Petty Officer, the Admiralty has forbidden your depth charge modification. Their concerns about safety are valid. Modifying explosive fuses aboard an operational warship creates risks the Admiralty can't accept. You are ordered to stop working on depth charge modifications. Fletcher had tried to argue the tactical necessity. Sir, German U-boats are diving below our depth charge's effective range. We're conducting attacks that can't possibly succeed because we are exploding charges 100 feet above our targets. My modification would allow us to reach depths where U-boats actually operate. Petty Officer, I agree with your assessment. I endorsed your proposal specifically because I believe you are correct about German depth capabilities. But the Admiralty has spoken. Unauthorized ordnance modification is forbidden. I cannot allow you to continue. Sir, with respect, convoys are being slaughtered because our weapons can't reach enemy submarines. Waiting for the Admiralty to develop proper solutions means watching ships burn for the next 18 months while procurement processes run their course. Petty Officer, I understand your frustration, but orders are orders. You will not modify depth charges. That's final. Dismissed. The order was clear and absolute. Fletcher had saluted, left the captain's cabin, and decided that sometimes preventing avoidable deaths mattered more than following orders that assumed procurement timelines were acceptable when the alternative was losing the Battle of the Atlantic. He'd continue developing his modification, install it covertly on depth charges in the ship's magazine, and let results prove whether Liverpool shipyard engineering was adequate for naval ordnance or whether the Admiralty's concerns about unauthorized modifications were justified. Either way, he'd rather face court-martial after proving the modification worked than follow orders while watching U-boats escape attacks that should have killed them, building the forbidden fuse delay. Fletcher's modification design was mechanically simple, which was exactly why he believed it would work. Complicated systems failed in complicated ways, but simple mechanical delays responding to pressure were reliable because physics was consistent. The standard Mark 7 depth charge used a hydrostatic fuse that responded to water pressure, detonating when pressure reached levels equivalent to 250 feet depth. Fletcher's modification added a mechanical delay between when the pressure threshold was reached and when the detonator fired, allowing the charge to sink an additional 130 feet before exploding. The delay mechanism was built from salvaged clock mainspring, brass tubing, and a simple escapement mechanism he machined in the ship's workshop. When water pressure reached 250 feet equivalent, instead of immediately triggering detonation, the pressure would begin unwinding the clock spring. The escapement mechanism controlled unwinding speed, creating a precise 8-second delay, exactly the time required for a depth charge to sink from 250 feet to 380 feet at its terminal velocity in seawater. He fabricated 6 delay mechanisms during night watch shifts over 5 days, working in the ship's machine shop after regular maintenance duties were complete. Each mechanism was identical, machined to the same specifications, using the same materials, calibrated to provide the same 8-second delay. The precision was critical. Too short a delay, and charges would detonate above diving U-boats. Too long, and they'd sink past the target before exploding. Installation required disassembling the depth charge fuses, inserting the delay mechanism between the pressure sensor and the detonator, and reassembling everything to appear completely standard from external inspection. Fletcher performed installations on 6 Mark VII charges in the ship's depth charge magazine, carefully documenting which charges contained modifications using innocuous markings that only he would recognize. The complete modification weighed approximately 6 ounces, cost nothing in procurement, all materials salvaged from maintenance scrap, required basic machinist skills and pressure systems knowledge, and would either prove that German submarines were routinely diving below British weapons reach or would fail and potentially result in Fletcher's court-martial for unauthorized ordnance tampering. On the 9th of March, HMS Starling achieved sonar contact with a U-boat that had been shadowing convoy HX-228. The tactical situation was straightforward. German submarine detected at 400 yards range, diving to escape attack. Escorts conducting standard depth charge attack using 30 charges. 6 of those 30 charges contained Fletcher's unauthorized modification. In 90 seconds, either the modification would work and Fletcher would prove the Admiralty wrong, or it would fail, and Fletcher would prove the Admiralty's concerns about unauthorized modifications were justified. 380 feet to vindication. HMS Starling's attack began at 14:23, with the ship passing directly over the U-boat's last known position. Depth charges rolled off stern racks in the standard pattern. 6 charges set to detonate at 250 feet. 6 charges, Fletcher's modified units, set to reach 380 feet. The charges entered the water and began their descent, spreading in the pattern designed to create an overlapping kill zone. If the submarine remained at depths standard depth charges could reach. At 250 feet depth, the standard charges detonated according to design. 6 massive explosions created by approximately 600 pounds of Torpex explosive per charge. The explosions were powerful enough to be felt aboard HMS Starling, as deck plates shuddered from the pressure waves. Standard doctrine assumed that a U-boat within the kill radius of those explosions would be destroyed or severely damaged. Intelligence reports and operational experience suggested otherwise. German submarines routinely survived such attacks by diving below the detonation depth. 8 seconds after the standard charges detonated, exactly the delay Fletcher had designed, the 6 modified charges exploded at 380 feet. These explosions were deeper than any depth charges had detonated in British anti-submarine warfare history, reaching depths where German submarines believed they were safe from attack. The pressure waves from these deeper explosions propagated upward and outward, creating kill zones at depths standard British weapons couldn't reach. U-boat U-432, commanded by Captain Lieutenant Hermann Eckardt, had dove to 350 feet when attacked, standard German defensive procedure that had worked successfully through dozens of previous encounters with British depth charges. Eckhardt's crew had heard the 6 standard charges detonate above them and had begun relaxing, assuming the attack was over and they'd survived another encounter by diving below British weapons reach. Then the modified charges detonated at 380 feet, 30 feet below U-432's current depth. The pressure hull absorbed the shock wave from multiple nearby explosions occurring below the submarine rather than above it. Seams cracked, rivets failed, internal piping ruptured, electrical systems shorted. The submarine's structural integrity was compromised catastrophically. Within seconds, seawater was flooding multiple compartments as the pressure hull's failure cascaded from localized damage to complete structural collapse. U-432 sank to crush depth and imploded, killing all 44 crew members. HMS Starling's sonar operators heard the unmistakable sounds of a submarine's hull collapsing under pressure. The grinding, tearing sounds of steel failing under stress no pressure hull could withstand. Debris field evidence appeared within minutes. Oil slicks spreading across the surface, wooden debris from internal fittings, and eventually German uniforms and personal effects confirming the kill. Fletcher, watching from the stern deck, recognized immediately what had happened. The standard charges had detonated harmlessly above the U-boat. His modified charges had detonated at the correct depth, achieving what standard British weapons couldn't accomplish because they reached depths where German submarines actually operated rather than where doctrine assumed they operated. He'd proven his point through a dead U-boat and 44 dead Germans, which meant he'd either face commendation for tactical innovation or court-martial for unauthorized ordnance modification, depending on how institutional politics resolved the contradiction between success and regulatory violation. Questions command couldn't ignore. Lieutenant Commander Gretton's initial reaction to the attack's success was professional satisfaction, followed immediately by institutional concern. He called Fletcher to his cabin at 15:30 hours, after confirming the U-boat kill through debris field analysis. Petty Officer Fletcher, sonar confirms we destroyed a U-boat. This is our first confirmed kill in 8 months of anti-submarine operations. It's also interesting that the submarine was destroyed by explosions that occurred at depths beyond our standard depth charges maximum setting. Fletcher had prepared for this conversation. Sir, 6 of the 30 depth charges employed in the attack contained modifications I developed allowing deeper detonation. The U-boat was destroyed by those modified charges exploding at 380 feet, 130 feet deeper than standard charges reach. Petty Officer, I explicitly ordered you not to modify depth charges after the Admiralty rejected your proposal. You disobeyed direct orders. Yes, sir. I assessed that destroying U-boats mattered more than following orders based on Admiralty assumptions about German submarine depth capabilities. German submarines routinely dive to 350 feet or deeper. Standard British depth charges can't reach them. My modification can. Gretton was silent for a long moment, clearly calculating how to handle subordinate who'd violated explicit orders but achieved the first U-boat kill in the ship's operational history. Petty Officer, you understand I should recommend court-martial for unauthorized ordnance modification? HMS Starling's success rate transformed immediately after Fletcher's modification entered service. Between March and May 1943, the ship destroyed 7 U-boats in 11 encounters, a 64% kill rate that exceeded the entire 2nd Escort Group's performance for the previous 12 months. Other escort commanders noticed, inquired about Starling's tactics, and learned about Fletcher's depth charge modification through informal networks between engineering personnel. By late April, 3 other destroyers in the 2nd Escort Group had machinists replicating Fletcher's delay mechanism, building modified depth charges using salvaged materials and sharing technical specifications through unofficial channels. By early May, escorts from other groups were requesting details about Starling's secret weapon and implementing similar modifications after learning the design required only basic machinist skills and materials available aboard any warship. The Admiralty's response evolved from prohibition to grudging acknowledgement as statistical results became undeniable. In February 1943, British anti-submarine forces achieved 7 confirmed U-boat kills across all Atlantic operations. In April, after Fletcher's modifications spread through escort groups, confirmed kills reached 23, a 300% increase that couldn't be explained by improved tactics or better detection equipment. The common factor was depth charges, detonating at depths beyond standard 250-foot settings, reaching German submarines that had learned to dive below British weapons' effective range. German U-boat command noticed the changed tactical environment through after-action reports from surviving submarines. Captain, who'd previously considered diving to 350 feet, reliable defense against depth charge attacks, reported that explosions were now occurring at depths that had been safe, and that pressure hull damage was occurring even when submarines dove to maximum operational depths. U-boat operational orders were revised in May 1943 to reflect the changed threat, but the fundamental problem remained. German submarines couldn't dive deeper than their pressure hulls allowed, and British depth charges could now reach any depth German submarines could operate at. Between March and August 1943, the tactical balance in the Battle of the Atlantic shifted decisively in Allied favor. Multiple factors contributed: improved radar, better tactics, more escort ships. But depth charges reaching operational depths where U-boats actually operated, rather than where doctrine assumed they operated, was quantifiably significant. U-boat losses increased from an average of 10 per month in early 1943 to 41 per month by May, while merchant ship losses decreased correspondingly. The modification that the Admiralty had forbidden as unauthorized and dangerous had transformed British anti-submarine effectiveness through simple mechanical engineering that reached targets standard equipment couldn't, the recognition that came with court-martial threat. On the 23rd of May 1943, Petty Officer Fletcher received orders to report to Admiralty headquarters in London. He assumed he was finally facing court-martial for 8 months of unauthorized ordnance modifications. Instead, he found himself in a conference room with Captain Frederick Walker, the Royal Navy's most successful anti-submarine warfare commander, representatives from Admiralty Ordnance Board, and staff officers from Western Approaches Command. Captain Walker opened the meeting. Petty Officer Fletcher, between March and May of this year, escorts employing your unauthorized depth charge modification achieved 68 confirmed U-boat kills, approximately triple the kill rate achieved using standard equipment during the same period. Your modification has fundamentally altered anti-submarine warfare effectiveness. The Admiralty owes you gratitude for tactical innovation that's helping win the Battle of the Atlantic. Thank you, sir.